In this video, we will be going over the properties of logarithms. Before we do that, we need to recall a couple of things. First is what a logarithm actually is. And a logarithm is an inverse of an exponential function. So a logarithm will look like y is equal to log base a of x if and only if x is equal to a to the power of y. Keep in mind that both of these things are the same thing. So they both say the exact same thing. And we will need to be able to move from logarithmic to exponential and exponential to logarithmic. The next thing that we went over was the general parent function of log x, which looks like so. And we need to be able to apply transformations, shifts, shrinks, and everything that we went over in chapter 1. The next thing that we went over were the basic properties of logarithms. So log base a of 1 will equal 0, because a to the 0 power is equal to 1. Log base a of a is equal to 1 because a to the first power is equal to a. Log base a of a to the x will equal x, and a to the power of log base a of x will also equal x. And that's just a demonstration of the inverse property. And finally, the one-to-one property, if log base a of x is equal to log base a of y, then x will equal y. And then the last thing that we went over were the natural logarithms. And a natural logarithm is just log base e of x. So both of these equations, again, are the same thing, just with a base of e. And all of those different properties still apply. So the first thing we need to go over is the change of base property. And the change of base, at times we may want to change the base of a logarithm either for easier calculation or sometimes just a simpler expression that we can cancel things out with. In order to change the base, from base a to base b, we need to take the ratio of log base b of x and log base b of a. So log base a of x will equal log base b of x over log base b of a. In order to change the base from a to base 10, log base a of x will equal log x over log a. And remember that because there is no base in these logarithms, it is assumed to be 10. In order to change the base from base a to base e, we take log base a of x, and that will equal the natural log of x over the natural log of a. So some examples of this. Let's say we wanted to change log base 4 of 25 to base 10, base e, and base 2. So in order to change log base 4 of 25 into base 10, we take the ratio of log of 25 over log of 4. In order to change log base 4 of 25 into base e, we take the natural log of 25 over the natural log of 4. And in order to change it to base 2, we take the log base 2 of 25 over the log base 2 of 4. So this last blue example is a good reason why we do this at times. This can simplify to log base 2 of 25 over 2, because the log base 2 of 4 is equal to 2. As another example, we can do the same thing for log base 2 of 7. So in order to change that to base 10, we take the ratio of log of 7 over log of 2. In order to change this to log base e, we take the natural log of 7 over the natural log of 2. And it's actually already in log base 2, so our job here is done. Next, we need to talk about a couple more properties of logarithms. The first is the product property. What this says is that if we have a product of two things or more inside a log, we can take the sum of those logs. So log base a of u times v is equal to log base a of u plus log base a of v. A good way to remember this is the product rule for exponents. So if we have a to the u times a to the v. We're simply adding those exponents together. The next property is the quotient property. So if we have log base a of u divided by v, that is also equal to log base a of u minus log base a of v. Again, a good way to remember that is the quotient property for exponents. So if we have a to the u power over a to the v power, we're taking the difference between those exponents. And then finally, the power property. If we have log base a of u to the power of n, we can rewrite that as n times log base a of u. So we just bring that exponent out front. And again, a good way to remember that is the power property for exponents. So if we have a to the u power and then take that to the power of n, we are multiplying those exponents. So we will be using these properties in order to expand or condense logarithmic expressions. So a couple of examples of that, we want to use those properties of logarithms and rewrite the following. So the first one says the natural log of 2 divided by 27. We can use the quotient property in order to rewrite that as the natural log of 2 minus the natural log of 27. The next one, log base 5 of the cube root of 5. First, I'm going to rewrite the inside. We can rewrite that as 5 to the 1/3 power. And then use the power property. So this is equal to 1/3 times the log base 5 of 5, which this log base 5 of 5, that's just equal to 1, so those cancel, and this is equal to 1/3. The next one says that the natural log of e to the 6 minus the natural log of e squared. So again, using the power property, we can rewrite this as 6 times the natural log of e minus 2 times the natural log of e. Again, using properties from the last class, the natural log of e is just 1, so that crosses out, and again, this one crosses out as well. So we're left with 6 minus 2, which is just equal to 4. The next one says the log base 4 of 5x cubed times y. So in this one, we're going to expand just a little bit. We have a product inside the parentheses, so we can rewrite that as the sum of each of these things. So we can rewrite it as log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. But this isn't totally expanded yet. Log base 4 of 5 is as simple as it can get, but log base 4 of x cubed is not. So using the power property, we can bring this 3 out front. So this is equal to plus 3 log base 4 of x. And this log base 4 of y is still as simple as it can get. So then this is your answer. The next one says 1/2 log of x plus 3 log x plus 1. Using the power property, we can rewrite this first part as log of x to the 1/2. And this second part we can rewrite as log of x plus 1 cubed. And because there's a plus sign in the middle, we can multiply those two things together. So then this is equal to log x to the 1/2 times x plus 1 cubed. The next one says 2 times the natural log of x plus 2 minus the natural log of x. So this first part we can use the power property for, so we can rewrite this as the natural log of x plus 2 squared minus the natural log of x. Now we have a difference, so we can rewrite this as a quotient. So this can be rewritten as the natural log of x plus 2 squared divided by x. So the next thing I want to do is to do a couple of examples that touch on everything that we've done so far. So these exercises can be found in 3.3. And the first set of problems that I'm going to do say to rewrite the log as a ratio of common logarithms and of natural logarithms. So keep in mind, common logarithms means base 10, natural logarithms means base e. So number 7 says to rewrite log base 5 of 16 into a natural log. So we can do that by taking log of 16 and dividing that by log of 5. This is the change of base to base 10. In order to change that base into base e, we can take the natural log of 16 over the natural log of 5. Number 12 says log base x of 3/4. So we can do kind of the same thing. So log of 3/4 over log of x. And then for natural logarithms, we can take the natural log of 3/4 over the natural log of x. The next set says to use the properties of logarithms to rewrite and simplify the expression, so either condense or expand. Number 24, log base 2 of 4 squared times 3 to the 4th. We can rewrite this as a sum of two things. So we can rewrite it as log base 2 of 4 squared plus log base 2 of 3 to the 4th. And we can simplify this even more using the power property. So this first part can be rewritten as 2 times log base 2 of 4 plus 4 log base 2 of 3. And this left-hand term, log base 2 of 4, is just equal to 2. So 2 times 2 is 4 plus 4 log 2 of 3. That would be our answer. Number 27 says to rewrite the natural log of 5e to the 6. Again, we can split this up into the natural log of 5 plus the natural log of e to the 6th. The natural log of 5 will stay as is, and we can rewrite the natural log of e to the 6 as 6 natural log of e. And again, using the properties from the last class, the natural log of e is just 1. So this is equal to the natural log of 5 plus 6. The next set says to find the exact value of the logarithmic expression. So number 29, log base 3 of 9. This is saying 3 to what power is 9, so this is just equal to 2. Another way to look at that is log base 3 of 3 squared, which we can rewrite as 2 log base 3 of 3. Log base 3 of 3 is just 1, so we're just left with the 2. Similarly, number 31, log base 2 of the 4th root of 8. I'm going to rewrite 8 to the 1/4 power as log base 2, 8 to the 1/4. And then I'm going to rewrite 8 as a base of 2. So if we simplify this a little, the inside will simplify to 2 to the 3/4. Which we can then use the power property to get rid of the exponent. And then the log base 2 of 2 is just 1, so we're left with 3/4. Number 32, log base 6 of the cube root of 6. Again, we can rewrite this as log base 6 of 6 to the 1/3. Using the power property, we can get rid of the 1/3. So we're left with 1/3 log 6 of 6. Log 6 of 6 is just 1, so we're left with 1/3. And number 41, the natural log of e squared plus the natural log of e to the 5th. We can rewrite this first part as 2 natural log of e plus 5 natural log of e. These natural logs of e simplify to just 1, so we're left with 2 plus 5, which is just equal to 7. A couple more examples. Again, these are at the end of 3.3. This problem set says to expand the logarithm as a sum or difference. So number 46, log base 3 of 10 times z, we can rewrite as the sum of two logs. So we can rewrite as the sum of log base 3 of 10 plus log base 3 of z. Number 53, we have the natural log of x times y times z squared. That is, we can rewrite the natural log of x plus the natural log of y plus the natural log of z squared, which we can then again simplify as the natural log of x plus the natural log of y plus, using the power property, 2 natural log of z. Number 63, log base 5 of x squared divided by y squared times z squared. We have the ratio of two things, which means we're taking the difference. So we can rewrite this as log base 5 of x squared minus log base 5 of y squared times z cubed. And then we have to simplify a little bit more. So this first part we can rewrite as 2 log 5 of x minus log base 5 of y squared plus log base 5 of z cubed. Now in this problem you need to be careful because this negative will distribute to both of these things. And again, we still have to simplify. So the outside is correct, so 2 log base 5 of x, and then minus 2 log 5 of y plus 3 log 5 of z. And that'll be as simple as that, or that is as expanded as it can get. Number 67, this problem set says to condense the following logs. So the natural log of 2 plus the natural log of x, that is the sum of two natural logs. So we can rewrite this as the natural log of 2x. Number 76, 2 natural log of 8 plus 5 natural log of z minus 4. The first thing we're going to do is use the product property. So we can rewrite the first part as the natural log of 8 squared, and the second part as the natural log of z minus 4 to the 5th. Now these two things are being added together with the same base, so we can rewrite this as the natural log of 8 squared times z minus 4 to the 5th power. And then 83 is a little bit longer. I'm going to first condense the inside of the parentheses. So we can rewrite this as log base 8 of y plus log base 8 of y plus 4 squared. Then we can take care of the sum inside. So we can rewrite this as log base 8 of y times y plus 4 squared. and everything else stays the same. Then we need to take care of this 1/3 on the outside. Again, using the product property, so this can be rewritten as log base 8 of y times y plus 4 squared, and all of that will be taken to the 1/3 power, and then minus log 8 of y minus 1 on the outside. Now everything on the left is simplified, everything on the right is simplified, and there's a difference, so we can rewrite it as the ratio of these two things, which will look a little bit messy. So our final answer would be log base 8 of this entire thing, so y times y plus 4 squared to the 1/3 divided by y minus 1. So I realize that was a lot of examples, but hopefully it touches on everything that we've done and it helps reinforce all of those notes. Some key items to take away, things we need to know. The change of base formula, so changing from base A to base B, we're just taking the ratio of log base B of x over the log base B of A. Changing from base A to base 10, if we have log base A of x, in order to change that to log base 10, we take the ratio of log x over log A. In order to change from base A to base E, we take the natural log of x over the natural log of A. And then there are three properties that involve expanding or condensing logarithms. The first is the product property. So if we have log base A of u times v, we can split the u and v up by taking the log base A of u plus the log base A of v. The next is the quotient property. So if we have a ratio of two things inside parentheses of a log, we can split that up with a difference. So log base A of u divided by v is equal to log base A of u minus log base A of v. And then the last is the power property. So if we have log base A of u to the n, we can rewrite that as n times log base A of u. So we can get rid of exponents inside the parentheses of a log. And as of right now, those are the things we need to know about logarithms, their properties and changing bases.